Before discussing how we integrate power into program design, I think it's important to understand who would need or benefit from power training. Now, the obvious population that's going to benefit from power training is the population of athletes. Power is probably the largest determinant of sprinting performance, vertical jumping, change of direction, and all of these markers of athleticism that we can develop through training. So obviously power should be incorporated into athlete training. But for general population or the average adult client, power is also very important because as we age, we have an age-related loss, not only in muscle size, but muscle strength. And we actually lose power at a faster rate than we lose strength. So what we want to do is offset this natural decrease in power. We also want to try to prevent falling. Fall prevention, one of the things that can help us to prevent falling is being able to catch ourselves. But catching yourself and preventing a fall requires the rapid application of force, which is really power. So both athletes and general population adult clients can benefit from power training, but how the power training is integrated into programming is where things might differ. The training guidelines for power can be seen in the table on the top left. And so the rep range is anywhere from 1 to 6 repetitions, and the loads are relatively light to moderate, anywhere from 30 to 70% of the 1RM. And they're light because they need to be moved explosively. Power is that rapid application of force, or force times velocity. So there's this speed component to power training, which is why the loads are relatively light to moderate. From a rest interval standpoint, we're looking for anywhere from 2 to 5 minutes. We want kind of a complete metabolic recovery if we can in between our sets, just to maximize motor unit recruitment and all of those things on every set. If we get a little bit more specific when it comes to power training, we realize we can separate it into 2 different types. We can have what's called light implement power, and this is jumps, plyometrics, and medicine ball type of exercises. These things are performed very, very fast because, again, the implement is very light. You're either just moving your body weight or perhaps a 4-pound or 6-pound medicine ball. But we can also have what's termed heavy implement power. And this is where we're moving loads fast, but there's actually a little bit more load that we're trying to move. So again, 30 to 70% maybe of that 1RM. Examples of these might be Olympic lifts and their variations. If you're not familiar or don't remember, the 2 Olympic lifts can be seen here. Not only can they be used in training, but the components and the variations of these 2 lifts are often used in training as well. But overall, when it comes to power work, then we need to be mindful of exercise selection. It's got to be conducive to an explosive tempo. The load recommendations for power training are pretty wide. You see anywhere from 30 all the way up to 70 or 80% of the 1RM being recommended. And the reason is because power can be separated into sub components such as speed, strength, and strength speed, but that's beyond the scope of this discussion. So what we can look at now, though, is that the actual load for power will depend on the exercise being used and the lifter's proficiency or technical abilities. But the key is using a load that can still be moved relatively quickly. And you can measure the speed of repetitions by using what's called velocity-based training. If I draw your attention to the data on the right, what we're looking at is what would be known as a load velocity profile for somebody doing a back squat. And so you can see various loads on the bar in the left-hand column. So 150 pounds on the bar. And then how fast did they move it? And what you can see in this example, it was 1.4 meters per second. Well, the resultant power then, power being kind of force times velocity, would give us about 210. So what we can see is for each of these escalating loads, we're getting a corresponding decrease in velocity and some type of change in power. Sometimes power is going up and sometimes power is going down. And so in this particular set of data, we can look and see, well, where is the athlete producing their highest power? And as you can see, it happens to be at 175 pounds, where their power output is 227. Well, for this particular athlete then, this is 300-pound 1RM. They happen to be reaching peak power at 175, and that's about 58% of their 1RM. When it comes to programming power, it doesn't warrant any type of change in the overall program from a structural standpoint. You can add power to a full body program or to a split body program, and it doesn't necessarily fit into an upper body or lower body day categorically, because power to a degree is considered a total body type of thing. Anyways, exercise prescription 2 is going to discuss power training in more detail. But what we can see is if you draw your attention to the right-hand side, from an order standpoint, we're going to do our warm-up. And then if we are doing power training, it will be done very early in the session. Now I have speed and change of direction here because that's very explosive as well. So if that's being done, it's done before power work. In this example, let's suggest it's not being performed. So what we can see is very early in the session, we would do the ballistic work, then we would do the loaded power work. If maximum strength or heavy type of work is done, it would come next, and then the general strength work would round out the workout. This is an example of how we can add power to our full body program, and this program could be repeated on Monday, Wednesday, and Friday. Now, early on in the session, of course, right after the warm-up, we're going to get our power work in while the nervous system is nice and fresh. We'll start with the light implement power. So in this example is a box jump. It's just a body weight type of thing. And we're going to do 3 sets of 5. Second, we have what we would call our heavy implement power. And in this example, we've chosen to use the hang snatch. The example of the hang snatch can be seen here. And from a programming standpoint, we've decided on 3 sets of 3 with 65% of the 1RM. Now the remainder of the workout just looks like our standard full body training session. It's 3 sets of 10 in a well-balanced full body workout. Of course, depending on the phase of training, this could be 3 sets of 8, it could be 3 sets of 12, etc. But this is just an example of how power can be implemented and integrated into your existing full body program.